Okay, now let's go with the since we have studied about all the pressures, but how do you actually measure the pressure? Okay, so there are different devices that calculates the pressure. So simple form of pressure measurement devices are known as manometers. Okay, so there are simple manometers, there are differential manometers. Okay, so these devices are used for measuring pressure at a fluid, okay, or at a point in a fluid by balancing the column of fluid by some other fluid. Okay, so there will be basically two different types of fluids sometimes, and using these two different types of fluids we actually try to measure the balance, or try to measure the pressure. Okay, so in case of simple manometers, we have piezometer, U2 manometer, and single column manometers. So let's see one by one what are these piezometer, U2 manometer, and single column manometers. Okay, so if you want to understand better, you can also use this link here. I have given the link. Click on this link and then see for your better understanding. So let's move on. So here first one is piezometer. Okay, so in piezometer, how do you measure the pressure? So pressure is, as I told you, you have general rule like pressure is equal to rho g into times z. Okay, so z is sometimes replaced with h also here. So you can see here h, so rho g into h, so Newton per meter square. So that is pressure. So with the help of pressure, so here how do you measure? So this is simple piezometer. Okay, so it's used for measuring the pressure of a fluid in any column of fluid. Okay, so this is just a cross section. So if this looks actually a pipe here. Okay, and this pipe, and then you cut this pipe, and then you see this cross section here. Okay, so this is basically a pipe here. Okay, so when you cut this pipe, and you see that this is the fluid, so inside this fluid you make a small hole. Okay, like small hole here like this, and you insert this tube here. So based on the rise and fall of this tube, you can actually calculate what is the pressure inside this tube. Okay, or inside this pipe here, inside this. So this pressure, as I told you, pressure is acting here, right, due to move fluid here moving. So because of this pressure, so this will allow this liquid to flow up this tube here. Okay, so based on this level, how much the water level rises in this piezometer. Okay, this is known as actually a piezometer. Only this part is piezometer. This is actually your pipe here. Okay, so based on how much water rises up into this tube here, you can calculate the pressure inside this pipe here, inside this point here, A. Okay, what is the pressure? So based on this formula here, so that is known as your piezometer. Okay, so now moving on, we have U2 manometers. Okay, in U2 manometers there are we use it's U2 is because let me change the screen here color. So because the nature of this tube is U-tube, okay, so that's why it is known as U-tube. Okay, so and that black filled one here, the filled one is actually your mercury. So this is just same here. This is the pipe here, so pipe is flowing. Okay, so in this direction pipe is flowing like this pipe is flowing, so inside the water is flowing. So we want to find out what is the pressure inside this point. Okay, so the point is marked as point B here. So if you want to find out the pressure, so you just insert a tube. Okay, so this tube here, U tube, so you insert the U tube inside this U tube inside the pipe here, and then you see the difference in this mercury level. Okay, how much and the mercury is able to, how much this water inside the pipe is able to move this mercury. So the difference in this mercury right now from a datum AA is actually H2 minus H1. Okay, there's a difference in height of, okay, usually the datum here, I think there is a mistake here. So usually this AA dash has to be from the minimum mercury level. Okay, so it has to be from here. Okay, this should be your A. I think there is a mistake here, so that should be your AA, and H1 is the your height that liquid, and H2 is your this one. Okay, so based on the difference, what is the difference in your H1 and H2, so that is you calculate the gauge pressure. In case of vacuum pressure, so what happens is uh, and to let you know, this point is actually subjected to atmospheric pressure. So here it is here, the pressure is exerted due to the fluid. But what happens if this fluid is under vacuum? Okay, so that means atmospheric pressure will be higher, yeah, and vacuum pressure will be lower. So in that case, since atmospheric pressure will be higher, so mercury will move down. Okay, so it will move down, and then based on the minimum level of mercury, you see here, now it is correct. So based on minimum level of mercury, you measure the height h1 and h2. Okay, so height is from here to the mercury level, and from here to the another minimum mercury level. Okay, so that is how you calculate. Okay, so h1 is from point B to that mercury level here. Okay, mercury level here, and then h2 is from initial mercury level here, mercury level, from this mercury level to this mercury level. So that is your h2. So based on these two heights, we calculate the vacuum pressure. So you have to understand how the diagram, okay, based on the mercury level. So see here, so mercury level is down here, okay, lower than this side. So that's why the atmospheric pressure is higher this side. So you can say that this is under vacuum pressure. Okay, here mercury level is higher than this level, so you say this is gauge pressure. So pressure exerted by the fluid is more here. Okay, so this way you have to understand. And there are more links here, you have to see this link, they are very good understanding. So this is YouTube link. So this is a grade 6. Okay, so in class 6 they taught what are the manometers. So I think you can also go back and refresh yourself how the pressure is actually calculated using a manometers, YouTube manometers. So moving on, okay, so for gauge pressure and vacuum pressure, we calculate the pressure separately. Okay, so let's say for the gauge pressure, how you calculate. So considering that gauge pressure where you have mercury level higher side, so in that way case, okay, so here all the terminologies is given here. Okay, what is h1, what is h2? So h1 is basically height of the liquid above the datum line. So aa has to be somewhere here. Okay, so aa has to be here. Okay, so this has to be your aa line. Okay, so that is your datum line. h2 is also weight height of the heavy liquid. So usually that is a mercury, heavy liquid will be mercury above the datum line. S1 is specific gravity of that fluid in the pipe, and S2 is a specific gravity of the mercury. Rho 1 is density of that liquid, and rho 2 is your density of that mercury. So at that pressure aa, okay, so your pressure is equal. Okay, we are not considering this aa here, and the new aa is this one. So at this point, okay, so once this pressure has been equalized, so pressure at this 2 point will be equal. Okay, so pressure at this point, wait, let me zoom here, pressure at this point and pressure at this point will be equal. Okay, so in this way we have to find out what is the pressure in this left side system and what is the pressure on the right side of the system here. Okay, so equating left side equal to right side, then we actually calculate the pressure here. Okay, so now let's me zoom back. Okay, so on the left side of the column and right of the column should be same. So for the left side, okay, the pressure in aa above aa in the left column is, so p is basically this p is basically pressure at the point B. Okay, plus what is the pressure due to height h1. Okay, so at this point h1 is h1, so rho 1 g1 h1. So height from B to your mercury level, this mercury level is h1, so rho 1 into g into h1. So that is your pressure at the left column. Okay, this p is basically due to pressure here. Already pressure is exerted due to the liquid here. Okay, flowing liquid or non-flowing liquid, whatever liquid is there, it's already a pressure. And due to height also, there is also pressure here. Okay, due to height here, so that is the pressure. And now on the right hand side, so it is the pressure is basically due to the density of this liquid. Okay, so pressure will be equal to rho into g times h2. So what is the pressure? Basically we are finding the pressure at this point. Okay, you have to understand here, at this point, this is your AA. We are finding the pressure at this AA. Okay, so pressure at AA from the left side we have already calculated P plus rho g h1. So and pressure at this point, okay, the datum is rho 2 g into h2. So once you equate that, okay, you equate these two pressures and you'll get what you'll get is here, where is it? Let's just wait, it's very clumsy here. So what you get is you'll get this equation here. So pressure is this much. Okay, so the pressure which is acting in this point will be this much. Okay, so you have to equate these two pressure, only then you will get it. So in case of gauge pressure, in case of vacuum pressure, so as I told you, the datum will be at the minimum mercury level. So here it is correctly mentioned. So here, so it's the right portion here, AA is at the right point here. So now with respect to the left column and right column, so pressure at from this one and pressure at this one, okay, so will be equal to will be same. But you see here, pressure at this, since this is at the vacuum, okay, so since the vacuum, so pressure at this right hand side, pressure will at this point will be 0. Okay, so because here it is at vacuum, so pressure here will be 0. Okay, so that's why now we only have to find out the pressure at the left side. So pressure at the left side is already, P is already there, P is already there due to pressure of the fluid here. Okay, pressure of the fluid, P is pressure of the fluid, and rho 1 g1 h1 is due to the fluid here, small h1, and rho g2 h2 is due to the mercury at this minimum mercury datum. Okay, so based on this one you equate, and then pressure at the right hand side is equal to 0. So you equate that and you get pressure as negative. Okay, so because for the vacuum, so if the fluid is exerting, maybe it is sucking more. Okay, maybe because of vacuum pressure it's sucking more, so that's why it's this mercury level is moving down. So that's why there is a negative pressure. Okay, so that's why here when pressure is negative, and that means maybe it is a vacuum pressure. So you need to understand that.